So let's talk about how an object can gain charge. Some objects just intrinsically have charge, like protons are always positive, electrons are always negative, but then other objects might start off neutral and can gain a charge, like when I took the balloon and rubbed it on my head and I gave it extra electrons, so then it gained an overall net charge. So that method is called charging by friction, literally scraping electrons from one object onto another. So when you rub the balloon on your head, well, the balloon gets extra electrons, and your head, since it lost electrons, becomes positive, but the balloon becomes negative because it has those extra electrons. And so we can say this, that in general, the objects get opposite charges, assuming, of course, they start off neutral. Let's look at some other ways of charging up an object. Another way is charging by contact. Over on the right-hand side, we've got a schematic diagram of a device I'm going to be using shortly to show you how these objects can distribute charge, called an electroscope. But first, let's talk about this. This is called charging by contact, to transfer charge by touching. So let's say, for example, we have two spheres. We have one sphere charged to positive 6e, which means it lost 6 electrons, and the other sphere is neutral. And let's say we put a conducting wire in between, allowing charges to transfer. So why don't you go ahead and pause the video and then complete the picture on the right-hand side there to show the eventual distribution of charge. So here's the idea. The object on the left has a positive charge, the object on the right is neutral, and electrons from the object on the right see the big positive charge over on the left, and so they start going through the wire over there. But of course, we don't want to have too many electrons over on the left-hand side, otherwise they're going to be clustered together, and so it's sort of a balance. And in the end, we should have an even distribution of positive 3e on both spheres. We're still following the law of conservation of charge though, right? There's total of 6e, positive 6e in the system. There still has to be a total of positive 6e afterwards. We can't gain or lose charge from this closed system. Let's look at another example. Let's say now the left-hand sphere again starts with positive 6e, but the one on the right starts with negative 2e, and once again we put a conducting wire in between, and then pause the video and draw what you think the eventual distribution of charge will be. Well, hopefully, you've got positive 2e on both of those. There still has to be a total of positive 4e in the system, and we have to have conservation of charge, and now we're going to have an even distribution. The electrons will go back and forth until they're evenly distributed. Overall, still a positive 4e charge, but positive 2e on each. And so here's what we see for charging by contact. The total charge is shared equally as long as the objects are equal in size. That's not always going to be the case, but for this first level, we will consider it to be the case we'll always look at. If you go to higher levels of physics, then you'll see other situations happening.